This short video covers the 8D problem-solving process, specifically step D4, or root cause analysis, and a certain technique that can be used when one has very specific circumstances called paired comparison. In the 8D problem-solving process, we start with step D1, or discipline 1, which is to establish a cross-functional team to help us work together to solve the problem. In D2, we define that problem in scope and detail. D3, we take short-term corrective actions, or we call them containment actions, to mitigate customer risk. And then step D4, determine root cause. Within determine root cause, there is a method called paired comparison that can be very effective when we have a limited amount of data and a limited amount of samples to work with. Paired comparison, the basic assumption is that we apply a Pareto principle, that there are a vital few and the trivial many. Only a few input variables are responsible for a large part of output behavior, so only a small number of things cause most of the problems. In paired comparison, we are searching not for every single problem, but for a single dominant root cause. When we do paired comparison, we're going to take best samples and worst samples. The best ones we can find and the worst ones we can find. The difference between the best and the worst is often the single dominant root cause. So the process goes something like this. We begin with taking one good unit and one bad unit. We want them as close as possible in time, and we aim for the best and the worst units that we can find. Using those two units, the good one and the bad one, the best one and the worst one, we note the differences between those units. What are the visual differences? What are the dimensional differences? What are the mechanical differences? And we need to continue to collect that data. Let the data speak and follow the data. What is the difference? Then we take a second pair of a good one and a bad one, the best one and the worst one. And we repeat that step. We look for those two, for the visual differences, the dimensional differences, and the mechanical differences. Then we repeat this process with all the remaining pairs. Each one, we go through the best and the worst, the good one and the bad one. What's different? What are the visual characteristics, the dimensional characteristics, the mechanical characteristics? Where are they different? We don't take inconsistent differences into account. If we find a difference in the first pair but not in the fourth pair, we don't worry about it. We just look for what we find in our pairings in a consistent way. This sounds very simplistic, and it can be done in a lot deeper method. We're only providing an overview of a paired comparison method here, but generally speaking, after the fifth or sixth pair, the consistent differences between best and worst start to become very, very clear. This is a really good method to use for manufacturers of large equipment, for large items, for something where we don't have millions and millions to look at. We don't have thousands and thousands of pieces of data. We only have really limited sets. And then we can look at those, divide up the samples, divide the returns, divide the products into good and bad, best and worst, and start doing the paired comparison between the two to identify what the consistent differences are.